Okay, so let's start the lesson. We were discussing about the heat, unit number 9 we started, and we are in the page number 15. Page number 15. Thermal expansion. Thermal expansion. So we're going to speak about the thermal expansion and thermal contraction. So the word thermal, it refers for heat. Expansion means expanding, increasing by size, increasing by volume. So thermal expansion, combining it, refers to as with the heat you provide, an object increases the size. An object increases the size. So increasing the size of an object upon heating, upon providing the heat, is what we term as the thermal expansion. Thermal expansion. So any object, it may be a solid, liquid, or a gas, whatever it is, when you provide heat, when you are heating the object, there's a possibility that the object can be increased by the size. So let's say one example, this is the object. This was the object size initially. So this is the size of the object before heating, before you provide the heat. Okay. You are going to heat. Now after heating, what happened? This was the object size, right? So the object has been increased by size. Object has been increased by size. So, you know, the diagram that I'm showing you to give an idea about increasing or not. Otherwise, it doesn't mean that exactly by this thickness, it will be increasing by such a value, it will be increasing, not that idea. So this diagram shows you the size is increasing, that's all, right? So you can see here what's happening. The size of the object increases. The size of the object increases when you are providing the heat. When you are providing the heat. So this is before heating and this comes after heating. After heating, right? So why is this happening? Why is this happening? When we increase the heat, right? Temperature increases. When we are increasing the heat, temperature increases. That we have already learned. Heat, when you increase, it is giving a sort of energy to increase the temperature. When the temperature is increasing, kinetic energy increases. That means the random motion of the particles increase. Random motion of the particles increase. So now when we provide the heat continuously, temperature keep on increasing and the kinetic energy of the particles increase. So they randomly move faster. Okay. They move. So kinetic energy is anyhow there in the particles, and we learned about that, right? Can you remember? Absolute temperature means that is the temperature, the zero temperature where the objects become rest, the particles become rest. So apart from the absolute temperature, any temperatures we take, there will be a motion. According to the level of the temperature, different types of motion of the particles will be there, vibrational kinetic energy will be there, right? So when we increase the temperature, the vibrational kinetic energy keep on increasing. So the amount, the distance that the particle can displace or move or vibrate increases. That means its amplitude increases. Example, let's say this is a particle. Earlier it was moving like this. Okay, there's a gap. Now what happens when you increase the temperature? It obtains that energy and moves faster. So you see now what happens? The particular motion, the particular vibrational distance increase. So this is what we term as amplitude. Can you remember? A particle in a wave motion, how much it is displaced, that is called amplitude. So the amplitude increases. So when it is increasing the amplitude, what happens? It collides on one another and it's moving away. It's moving away. When it is trying to move away because of the speed of the particle is increasing, it is trying to move away one another. That means it's moving away, occupying a larger space. Occupying a larger space. So what happens? Totally the volume keep increasing. It doesn't mean that the particle is increasing by size. Okay, what's happening here? The particle occupying space becomes high. For example, let's say 50 people are there in a certain point, certain place. Now all these 50 people are closer to each other. Or let's say 5 people on a bench. Very simple example. 5 people on the bench. Okay, so you are closer seated on. Now let's say the temperature in the classroom is very high. What you are supposed to do? We are trying to move away from each other, right? to obtain, more space. Okay, so the same like the particles when they are closer, when we increase the temperature, they try to move away. So they occupy more space, increasing the entire volume. So this causes the thermal expansion, and this is what we refer to as expansion. This is what we term as expansion. So thermal expansion occurs because of increasing the heat, because of increasing the heat. Right? Now the same thing in the opposite way also happens. Now let's say somebody have increased the heat. Okay. Now because of increasing the heat, it is expanded. What we do now from this sides, okay, from this sides, opposite the reverse I am going to do. What is the reversing here? Reversing I am going to pull. I am going to pull. Reversing I am going to pull. When I am cooling it, what happens? From the original size or from the initial size, it gets closer. Now the particles come closer. Particles come closer. Coming closer from the initial size, they decrease, they come down to the volume. So they come closer, and the entire volume decreases. Entire volume decreases. And this is what we term as contraction. This is what we term as contraction. So thermal expansion refers to when you heat. When you provide the heat, the objects, when you provide the heat, the object size, the volume is increasing. That is thermal expansion. Thermal contraction refers to when you cool down, the object size reduces, maybe back to the original size, it comes closer to getting contracted. So these are the two theories that we are going to apply here in this lesson. Now, who will be getting contracted, who will be getting expanded? It may be a solid, liquid or gas, whatever. All the solid, liquid, gaseous materials, they can expand. They can expand. Okay, when you heat, when you provide the heat, they can expand. They can increase by their size. They can increase by their size. Meanwhile, reverse, they can decrease by their size when you are cooling them down, when you are reducing the heat. Okay, so by some activities, we are going to learn this part. Okay, so let's look at the tube now. Still going. Oh. Right. So the first two lines are given. Can you see on your tube? Thermal expansion and thermal contraction it is giving you. So could you please underline them? What is thermal expansion? What is thermal contraction? It is given. Please underline them. The increase in dimensions of a substance subjected to an increase in temperature, that means providing heat, is known as thermal expansion. That is the increase in its length, area or volume. Meanwhile, thermal contraction, the decrease in dimensions of a substance subjected to a decrease in temperature is known as contraction. That is the decrease in its size, length, area, volume. So that is called contraction. Okay. And please note this down on your writing book. Note this down on your writing book, please. Right. So some activities you are going to take now. Look at the first activity. I'm going to take a metal ball, right? So the metal ball, it is a solid object. I'm going to heat, right? So before heating, what I do have a stand. You can see there's a stand, a holder is there. And on that holder, we do have a ring. So same metal made ring, let's say. Okay, same metal made ring I do have. So through that ring, what I do, I'm going to send this metal ball in. So in the first image A, you can see the metal ball can be moved through this metal ring. Then what I do, I'm going to hit the metal ball. I'm going to hit the metal ball. After heating the metal ball for some time, now I'm going to move it again through the same ring. I could see it's stuck. It cannot be moved through. What is the reason? The reason is metal has been expanded. Because of I heat that, it has expanded, increased by the size, so it can't move through. Okay, it can't move through. So this concludes that metals can expand. Metals can expand upon heating. It is a solid, so solids do expand. Fine. Now let me ask you a question now. You want to send this metal ball once again through the same metal ring. What can you do? How do you make it? Can you tell me? Anyone can tell me that? So you want to somewhat, now it is stuck up, right? So somewhat you want to send it through the same metal ring. How do you do that? You can't change the metal ball, but you can play up with the heat. What can you do? Guys, you can speak. What can we do? Yes. So they say decrease the heat by cooling it. Okay. Fine. So they say by cooling the metal ball, you can do it. That's fine. So when you are cooling it, once again, it will be contract and come back to the same original position. You can do. Apart from cooling the metal ball, what can you do? Another way is there. Can you suggest me a method? No, you say you want to cool the metal ball. You can do the same. Without cooling the metal ball, what can you do? Exactly. Heating the ring. Heating the ring. Yes. We have to heat the ring. We have to heat the ring. Why? I told you. Can you remember the same metal made ring I told you? So same metal made ring means same way it would be heated up, same way it would be expanding. Expansion rate will be the same. So when you are going to heat the metal ring, it would be expanding. Same time if you are doing, it would be. Then what happens? You can send the metal ball through it. So whatever both the parts speaks about metals, the solids can expand upon heating. They cool down. When they cool down, they become contracted. So once again, this metal ball you are going to put it inside cold water or something. It cools down, releasing the heat, comes back to the same original position. Okay. Fine. So this activity shows that metals, solids can expand. That's it. A small activity. So go to the next one. Another activity is there. But before the activities, some applications are there. What are the applications? So where do we use this metal expansion or solid expansions? Some examples given. Now, when we are taking the iron rims, first example, okay. When we are taking the iron rims, okay, that basically the wooden cart wheels and also wooden cart wheels means cart wheel is made up of wood. So this wood, when you are straight away applying to be dragged towards, okay, or pulled or pushed along the road, it might be broken. So we need a metal rim, an iron rim is needed. But the thing is, right, straight away surrounding let's say I'm going to take a wooden ring. So this is the wooden ring, wooden cart wheel. So I want to apply an iron ring. So over that an iron ring, if I want to apply, definitely its diameter should be more than the wooden card, right? But the problem is one over the other when you are going to apply them, okay, and when you are pulling or pushing it, that the rings will be separated out. Rings will be separated out. So what are we doing here? In fact, what we do here is the wooden card's diameter, we are having a certain measuring. Less than the diameter of the wooden card, we are selecting an iron rim. So the iron rim must be less than the wooden card's diameter. Now you may think iron rim should be fixed over the wooden card, so it should be high in the diameter, but we are taking less. What we do then, taking a lower diameter, slightly less than the diameter of this wooden card we are taking, and we are going to heat the iron rim. When we heat the iron rim, iron expand or aluminium or whatever, basically iron rim they are using, it should be heated up, it would be expanding. When it is expanding, it goes expanded more than the size of the wooden card's diameter. So once it is expanded, we are going to fit it over. We are going to fit it over, right? So after fitting, now it is fitted over the wooden card and we leave it to cool down. When it is leaving down, it should be contracted, right? Should be contracted, right? But the thing is, to contract, it has no space to come close. So it will be finely fixed over the wooden card, being tightly connected. So it won't be coming out. So this is one application where we are using the iron, what do you call the expansion of solids. And the second one, right? Now imagine metal lids are there, right? Metal made lids are there over the bottle. Sometimes that will be stuck up. You can't open it up. You can't open it up. So what do you do? Okay, basically in the glass bottles, the wine bottles and all are there, right? So over there we do have a metal lid. So that's tightly packed up, let's say, tightly fixed. We can't open it. What do you do? We have to heat it. Slightly when we are heating the metal lid, it will be expanding. So after expansion, easier we can remove it out. But you know, when we are applying these theories practically, we have to be more concerned about the environment, the surrounding other factors also. Now, let's say you are going to do this for a plastic bottle, what happens? Plastic melts. No? It's a plastic bottle. Okay, plastic, what do you call a lid is there, you can't do that. Okay, fine. On a plastic bottle, you do have a metal lid, let's say. Still you can't. Why? Inside the metal lid, somewhat the plastic cap is there. So when you are going to heat the metal, that the heat will be transferred to the plastic also. So again, it will be melting because a higher heat you have to give. Okay. So we have to concern about that. And moreover, let's say, okay, fine, it is a glass bottle and it is a, what do you call, a metal lid is there, but it contains kerosene oil. Is it okay? Contains kerosene oil, you are going to heat it. Now whatever, it is dangerous. Okay. So practically when we are applying, we have to concern about the surrounding, also what it contains, what sort of factors are there, those things you have to concern. So whatever, now you see here, metal lid can be opened up upon heating because it expands on heating, right? So this is one, all right? And in railway tracks, you have seen, right? So when you are coming for the railway tracks, there are gaps between the railway tracks, right? Okay, there are gaps between the railway tracks. So railway tracks means not like this gap, okay? Something like, imagine now, so when you're gonna take the railway tracks, okay, the gaps are there between the tracks, have you seen? Right? These gaps are there, right? This is the place where the wooden parts are there. This is the place where the wooden parts are there. So over this only the train goes. So in between the rail tracks, there's a gap, right? Why do they have the gap? Why are they having the gap? Now, if they don't have a gap, while they are directly heated up by the sunlight, sun heat is given, right? When they are heated up, imagine now they are very closer like this. They don't have a gap. They are kept like this. Now they have to expand. No, they have to expand. So when they are expanding, now what happens? The only way to expand is they have to move over one another like this. Correct? So when they move one over the other like this, the train, it won't be moving straight, you know. It moves like a roller coaster. It goes up. Okay, so it won't be moving straight. So what happens? It won't be maintained within the track. So that there's a gap kept. During the heat, they expand, and during the night time, they cool down. Okay, they contract. So that the gap is kept on. Gap is kept on. Sometimes within the rail tracks also the gap is there. So I'm not speaking about this gap. Okay, this gap we don't have a wooden, we don't have a metal cap or something. It's a wooden part. Okay, wooden parts are kept, and somewhere the rocks have been mixed up together. So that is how it goes on. So I'm speaking about the gaps between the rail tracks. Gaps between the rail tracks. Okay, so this is also because of thermal expansion, and also the cable post when we are taking, right? So the posts are there. Between the posts, the wires are hanging down like this. The wires are hanging down in this way. They are not tightly kept. You may have thought of, okay, when you are looking at your surrounding area, all the wires are hanging down. The electric wires, cables, and everything, they are not tightly fixed. So we think that why do they want to make it hanging down? Why can't they fix it straight? This is because of when they are hanging down loosely when they are hanging down, and during the daytime, somewhat the heat is given and they have to expand, right? Because metals, right, expand. So when they are expanding, fine, nothing happens. But during the night time or during the cold time, they contract, right? So imagine they are already tightly connected. They are already tightly fixed up, like, okay, already tight. They have no hanging. Okay, hanging space is not there. So they are already tightly connected. Now during the daytime, during the night time and cold time, when they are trying to contract, they have no space to contract, come closer. So when they're trying to contract, what happens? There is a possibility that the wire or the metal cable could be broken, since the particles are coming closer. So that is why they are kept hanging. When they are hanging down and when they try to contract, still they have space to contract on without breaking, without damaging. So this is why usually these metal wires are hanging down. So these are few examples where we are using these metal expansion, or as the thermal expansion of solids. And some of the examples are also there. Have a look. Now, electric irons when you are using, do you all iron your clothes? Tell me. Do you use to iron your clothes? When you're ironing your clothes, have you noticed that there's a small lights there, right? Have you thought of why do we need that light there? Because we are not using the light there, right? A small light is there. A small bulb is there. And these bulbs, have you noticed sometimes when you iron for a long time, it turns off, giving a tick sound. Okay. It turns off. And after some time, again it turns on automatically. Can someone explain me about, or give me your idea? You can come in. Is that? What do you think about that? Some of them have learned this lesson at school already, so they should be able to give me the answer because they have already learned. What do you think? Why is that happening so? Yes, what do you think? The metal is heated. Do you know how to explain? Right. If you want, you can speak. I'm asking why, what is the use of that small bulb there? What is it doing? What is it doing there? Otherwise, we don't want a bulb in an iron box, right? Okay. Anyone can explain of? Reduce the heat. Okay. Abdurrahman, what do you think? Abdurrahman, Hikam, can you give me an answer? Yes. Rashid, what do you think?
No idea, sir.
No idea. Abdurrahman, Amar, why do you have this light? The bulb shows that the metal is heating. If the bulb turns on, the iron box is heating. If it turns off, it stops heating. Okay. Whenever the iron is heated, it would get on. It would get on. And when the heat is decreased, it gets off. Good. Give me answers, please. Now try, when you're trying, you can give me some answers. Correct or not, we'll discuss. Because I didn't ask anything which you don't know, right? Practically, you are using it. Okay, I'm asking why is this light? Okay, or how is this light used? In this iron boxer, sometimes in the rice cookers also you can see automatically turning on and off. When it gets heated, it gets expanded and the wire of light gets connected. Okay, good. You try. Fine. So what's happening here? Look at this. Can you see the diagram? Two diagrams are given. Oh, look at the first one. There are two pieces of metals we are using. Metal stripes we are using. Metal rods like we are using. Both of them can expand. Both the metals are different from one another. Both the metals are different from one another. They can expand as well. Okay. So these expansions are also different. Different ways they can expand. So what am I going to do? I'm using as up and down. One is given as, let's say, the shaded one. The other one is not shaded. Up and down is given, right? Upper part I'm going to use as a legs expanding one. The metal with a legs expansion. Lower one, okay, the rod below, it is having a high expansion, right? So it is something like this. Imagine both the rods are same like this, same by the length. But the upper one expands less, lower one expands more. And both of them together, they are connected to the circuit connection here. Can you see there? This is a circuit connection. The heater is there, the battery is there. Battery provides the current. Current passes through. When the current is passing through the entire setup, it still keep on heating. Still keep on heating. In electric energy is what used up. Electric energy is being converted to heat energy. That is how we are using the iron boxes. Okay. So now what we do here, when we are using this for a long time, the electricity is continuously given. The heat provides heat. It's converting the heat energy. Now, when the heat energy is increasing, these two metals will be expanding. One expands less, the other one expands more. One expands less, the other one expands more. So let's say the upper one is high expansion. Then what happens is the upper one is highly expanding. What happens? Then it will be expanding like this both together, coming down, coming down. The reason is, for upper one is more expanding, lower one is less expanding. It can't be going expanding like straight because both the points are connected at the same end. One over the other, they can't slide. Together, they have to move away. So they are attached here. So since they are attached here, upper one is expanding more means